Okay, so at the end of the last lecture, we were talking about implementing classes. I think we had we've created 3 classes with some fields. And that's basically it. So that's as far as we got, I think. So our classes, just to remind you, so here's the Stopwatch class, right? It's got nothing in it except the fields. If you actually write a program that makes some objects, it actually works, right? So you make a new point, you make a new counter, you make a new stopwatch, everything works fine, which is strange because we don't have any constructors, right? And so we learned that if you create a class with no constructors, the compiler makes one for you, right? So the compiler silently inserts a no argument constructor for you. The effect of the no argument constructor is to initialize all of the fields of the class to some default values that the Java language designers have picked. So the compiler generated constructor, all your numeric fields get set to 0. The Boolean fields get set to false. Any reference gets set. Any reference type field gets set to null, which works fine in most cases. So in a lot of cases, sorry, this is fine, right? But if you you are allowed to create your own, or to define your own no argument constructor. So if you want to be explicit about things rather than relying on someone understanding the language in enough detail to know what the default constructor would do, or what the compiler generated default constructor would do, you can make your own no argument constructor. And if you want your class to have more than one constructor, and you still want the no argument constructor, then you have to define your own anyway. So our no argument constructor for our point2 class is going to make a point whose coordinates are 0, 0. And it's very easy to do. So this is all you do. Right? We've got our fields x and y. Right? Now here's our constructor. The name of the constructor is always matches the name of the class. Right? So that's rule number 1. You have to remember that. No argument constructor. No arguments, right? There's no parameters in its parameter list. The constructor is public. I'm just checking. Okay, so the choice of access modifier here is the same as the choice. Oh, hey, I spelled coordinates wrong. Is the same as the choice of the modifiers for your fields. They can be private, public, private, package private, protected, or public. Now, for our purposes, today, everything's going to be public because we want to make our we want to provide constructors that anybody can use. Right? So what does it look like, right? So here's our constructor. What does the body look like? Well, I need to set x and y to 0. Right? So you can write this dot x equals 0 and this dot y equals 0. Now, what's with this funny keyword this? Do I actually describe this? Okay, I don't describe that. So this strange keyword this inside a constructor, right? So this is important, right? So all this stuff here in red is actually very important. Inside the constructor, the keyword this is a reference to the object that's currently being initialized. Right? So remember when a constructor is called, right? It's called when someone says new blah, right? In this case, new point 2. The reason someone is using new is to make a new object, right? So when that object is created, the reference to that created object is stored in the variable called this. Right? Now, notice this is not a field, right? So it doesn't show up here, right? This is a keyword in Java that lets the programmer refer to the object that's being initialized, right? So in other words, the compiler automatically makes the keyword this or the reference this available to you in the constructor. Okay, so that's fine. So this dot x means change that value of x to 0, and this dot y means set that value of y to 0. Now, you are allowed to write just x equals 0 and y equals 0 here. Okay, so if you use a variable, right, use a variable that's not a parameter, so that's important, right? Not a parameter, it's not a local variable, right? And the compiler looks to see if this thing here is a field, right? So in other words, let me just temporarily change this slide. Right? So this is, in fact, this works. Right? So when you do this sort of thing, right, the compiler says, hey, there's no parameter called x, there's no local variable called x. So is there a field called x? The answer is yes. Right? So in this case here, the compiler says, oh, they mean the field x. So you can write x equals 0 and y equals 0 here, and that works just fine. Right? It's a little, it's unclear to me what practice is in industry. Right? But the Java standard library, if you look at the source code there, they will always write this in front of the field. I think they always write this in front of the field. If you want to be explicit about whether or not you're accessing a field, inside the constructor, you can always use this. Right? And that's true inside of a method as well. But inside the method, this refers to something slightly different. So in all of the slides and all of the course notes, right, in all of the assignment solutions and in all of the assignments, whenever you see code that's provided by me, right, the fields are always accessed with this in front. Okay. But again, it is legal to write x equals 0 and y equals 0 here. Now this is a picture of what happens when you make a point to object, right? So this is every step illustrated from one single line of code. Right? So when you write point to p equals new point 2, right, a reference variable p is created somewhere in memory. So there it is. Again, it doesn't have to be at address 64. It's anywhere where there's a free spot in memory. Right? New allocates memory for a point to object. Right? So there's your point to object that gets created. Right? So remember how this is created. Right? You take the point to class, you make a copy of the class, you plunk it down somewhere in memory. Right? Again, it doesn't matter where it is in memory as long as there's free space for it. Right? That point to object has fields x and y. Point to constructor runs, right? And when the point to constructor is run, it gets the address of the object that's being created. Right? So in other words, the constructor receives the address 600A. Right? And that's because the constructor needs to know which object should it be filling in the fields for. Oh, just to confirm, any local var with the same name as the field will be resolved over the field with the same name. Yes. So Noah, sorry, I just saw your question there. Sorry. Let me just quickly flash forward ahead to another constructor to see if I can't show you an example. Probably all the way at the end. Here's an example. Okay, so Noah asks if you make a local variable, in this case a parameter that has the same name as a field, right? Then the parameter or local variable takes precedence over the field. So here's a constructor that lets you the user set both the x and the y coordinate, right? That x has the same name as that field there. That parameter y has the same name as that field there. So inside this constructor, if you just write x, you mean that x, and if you just write y, you mean that y. So here's an example where you must write this dot x equals x and this dot. I want to set the field x to whatever value that is, and I want to set the field y to whatever value that is. Right? Now, because the parameter takes precedence over the field inside of the method, I have to write this dot x if I want to get to that field there. You just write x equals x, that doesn't do anything. It just changes the parameter x to be equal to x, which does nothing. So yeah, that's what happens. Whoa, where are we here? Okay, so back to the slide here. Right. Okay, P appears. New makes a point to object. You're welcome. Point to constructor. Okay, so the point to constructor gets this address, right? Because the constructor needs to know which object should it be filling in the fields for. Right? So it gets the address 600. And that's what's stored in the parameter this. So the parameter this gets whatever value that is. Is set to whatever value that is. So inside your constructor, right? So this is the constructor that's running now, right? So I'm showing you a picture of the constructor. It's a method. Well, it's not a method. It has to run somewhere in memory, right? Anything that runs, any method or constructor that runs has to run somewhere in memory, right? You need room for the variables that are in the constructor or method and some other stuff as well. Right? So somewhere in memory, the constructor runs. Right? Again, it can run anywhere in memory as long as there's free space, right, for the constructor. for whatever needs to be stored in the constructor, right? The compiler automatically creates a variable called this, and it sets the value to whatever address of to the address of whatever object is being initialized. That 600 there gets copied into there. Right. Now the constructor runs. Right. So what does the constructor do? The constructor says this dot x equals 0. Right. So what's this? This is 600. So we come up to here. This dot x means that x there. Right. Equals 0 means that gets set to 0. Right. This dot y equals y means this. Right. So address 600 dot y means that field there. That value there gets set to 0. And finally, so the constructor's done. New is now done. New returns the address of that object. So P refers to the object at address 600. So that one little line of code, right, which looks simple, hides a lot of complexity. Okay, so that's the point 2 constructor, the point 2 no argument constructor. Right. Now remember our counter class, that's just the counter that counts upwards, right, in increments of 1. So our no argument constructor for the counter class, a sensible thing to do would be to initialize the counter to 0. You could choose to set it to some other value if you had good reason to. Right. In our case, because it's something that counts, it makes sense to set it to 0. So there's our field value. Right. This dot value gets the value 0. That's it. So that's nice and simple. Right. Again, what happens? Right. So a similar sequence of events happens when you call the no argument constructor for the counter class. Right. So C equals new counter. Right. So variable C appears somewhere in memory. New allocates memory for the object. So there's your object. Right. There's your field value. Counter constructor is invoked, passing the memory address of the object, right? So in other words, the constructor gets this address stored in the parameter this, in the variable this, right? So there's our point 2 constructor running somewhere in memory, right? What does the constructor do? It says this value equals 0. So what's this? Well, it's that object there. We come to this object here, look at the field called value, set it to 0, right? The constructor finishes running, new finishes running, and returns that address back, right? So that address there gets set to 558. And finally, the stopwatch no argument constructor. So remember the stopwatch. Our stopwatch has a start time, a stop time, and a field called is running. So we can set these. The no argument constructor has to set these to something. Right, you can pick whatever value you want. In this case, I'm going to use 0. Right. Again, in this particular case, doesn't matter. I don't think it matters because it doesn't actually matter what values you pick for the start and stop time, as long as they're the same. But in this case, it seems to make the most sense to set them to 0 and then set is running to false. So those are your no argument constructors. I guess the important things to remember here are you should remember why or what is the purpose of a constructor. The purpose of a constructor is to set the fields of the object, right? It has to give the fields some initial value. What does the keyword this mean, right? Inside a constructor? Well, this refers to the object that's being initialized. So this lets the compiler figure out which object is being initialized, and so which object's fields should be set. Okay. All right. Now, what about methods? We'll come back and implement some more constructors shortly. So a method lets an object perform some kind of computation. Okay. So in other words, it defines the behavior of an object. The set of methods is the set of behaviors that your object can perform. Sorry, defines the behavior for your object. Right now, everything we've been doing so far, we've been using a bunch of static methods. Right? So now we're going to implement non-static methods. Right? Remember, for a static method, When you use a static method, you always use the name of the class to call the method. Right? But now that we're making objects, we want to call methods belonging to the objects. So those methods are always non-static. So if you use an object to call a method, then that method is a non-static method. Right? It's a method that belongs to an object. Right? A non-static method is allowed to use any of the fields belonging to the object. Right? So for example, we can provide a non-static method that lets the user set the x and y coordinates of a point. Here's our set method for the point2 class. So what does the method look like? Access modifier, right? Return type, no static now, right? Because this is a method that belongs to an object. So access modifier, return type, method name, parameter list. Okay, so this method here is going to is supposed to set the coordinates of the point to new x and new y. Right? Now, how are the coordinates of the point stored in the object? Well, they're stored in the fields x and y. Set the x coordinate of the point to new x, you write this x equals new x, and you write this y equals new y. You are allowed to write x equals new x and y equals new y in this case, right? Because the compiler can figure out that when you just write x, you mean the field x. Because there's no x here or here, right? And there's no local variable x here. This method is a little funny, so you definitely haven't seen this before, right? So this particular method returns the value this. Right? So in other words, it returns a reference to the point that was just used to call the method. Oh, I didn't tell you what this means. Hang on. I don't actually tell you what it means. Okay, so that's a bit of an omission. All right, so inside of a method, the keyword this refers to the object that was used to call the method. So keyword this refers to the object that was used to call the method. So when you write p.set, right, 1, 1, then the value of this is equal to the value of p, right? So whatever object p points to, this points to, right? And so that lets the compiler figure out, okay, so what object do they want me to change the coordinates of, right? So they want me to change the objects of the that's pointed to by the variable p. Right? So this becomes analogous. This points to the same object that was used to call the method. Right? Why do we return this? So this is very unusual. You don't often see this, and you certainly don't normally see this as your first method. Right? So what is the reason for returning this? It's because somewhere else. So not inside the point2 class. Somewhere else, if you call set, right? So p.set 1, 1. Oops, sorry. Where did that get to? Here we go. Right. So if somebody writes this with a and p is a reference to a point2 object, right? Then p.set 1, 1. So that sets the coordinates pointed to by p to 1, 1. Right, and then right, that returns a value. Right? So it actually returns p in this case. Right? It returns the same it returns a reference to the same object that p points to. Right? And so what that means is that, oops, sorry, that's not what I meant. Right? This, all of that returns a reference, and it actually returns a reference to p, right? Or that's equal to p. And what that means is that you can use this to call another method. Right? So I can write p set 1, 1 x. Right? So I can write something like this, double x equals that. So I'm going to take the point p, I'm going to change its x and y coordinates to 1 and 1, right? And then I'm going to ask that point, what is its x coordinate? So that's what returning this lets you do in this example. Notice that in the contract for the method, that thing there tells you what the method is returning. It says it returns a reference to this point. That lets you chain. That lets you chain additional method calls onto the end of the method, onto the end here. So because that returns a reference to P, right, I can use that as another reference to call another method. And this turns out to be useful in this example, for this particular class. Right? It's not useful always. In this case, it turns out to be useful. So whenever you're working with these mathematical type objects, for example, you might want to change the coordinates of the point and then add a vector to this point, right, to move the point. Right? So here you can call the add method and move the point. But we'll get to that a little bit later on. You can add other methods, right? So you can add as many methods as you want. Limited by, so you can add as many methods as you want. The naming of the methods, there are some rules. So I can provide a method that lets the user set just the x coordinate of the point. Right? So here's an example where we have a method called x. Right? Changes the coordinates of the point to new x, returns a reference to the point that was changed. Right? So I want to change the x coordinates of this point to new x, so you just write this x equals new x. And again, return this in this particular example. Right. Again, I should emphasize that you don't always do this. Right. It's a lot of methods that change. It would not be unusual to see a point2 class where the method x returns void. Right. So in other words, doesn't return a value. You can let a client. You can provide another method that lets the user set just the y coordinate. Right. So again, method called y changes the coordinates to new y. Right, returns a reference to the point that was just changed. This dot y equals new y, and then return this. Okay, so those three examples of methods are what are called mutator methods. So you'll often see the term mutator and accessor, or getter and setter, right? So mutator methods are also called setter methods. Right, because they set or change the state of the object. Right, so any method that changes the state of an object is considered to be a mutator method. This is not a Java term. This is a general object-oriented programming term. So set, x, and y are all examples of mutator methods. An accessor method is a method that returns information about the state of an object, and it does not change the state of the object. Right? If it changes the state of the object, it's a mutator method. If it just returns information about the state of the object, then it's called an accessor or getter method. Right? It's called a getter method because a lot of the time the method name starts with get. Right? And for the mutator methods, a lot of the time the method begins with set. Right? The name of the method begins with set. So if I want to provide a method that returns the x or y coordinate of the point, right? It's very easy. Right. So here's the method called x. It has no parameters. This is an accessor method that returns the x coordinate of the point. Right. What's the x coordinate of the point? Well, it's stored in this dot x, so you just return this dot x. Here's a method called y. Returns the y coordinate of the point. Right. Where's the y coordinate of the point stored? Well, it's stored in the field called y. So return this dot y. So the methods, when you create a method, the first thing you need to do is you write down what's called the method header. Right, so that public something method name parameter list, that's the header of the method. Right, and it's made up of 5 parts. We're not going to talk about part 5 right now. First 4 parts, though, these will show up in every method, in every non-static method. So there's our set. There's the method header for the method set. Thing in front is the access modifier. So do I tell you what it means? Okay, so the keyword public means that any other class can see and use the set method. Right? So it means the same thing as it means for fields. The second thing is what is the type of the value that the method returns. This method header says that the method set returns a reference to a point2 object. The third thing is the method name. So in this case, the method name is set. And then inside the round brackets, that's your parameter list, right? Which is identical to a parameter list in C. Now, inside that parameter list, it's just the list of types and names of the inputs to the method. Right. So this parameter list says here, it has two parameters. Right. The first parameter is a double value. The second parameter is a double value. The names in the list have to be unique. Right? So I can't have double x in this case, right? Or I can't have double y and double y. So duplicate parameter names are not allowed in one method, right? You can certainly repeat the parameter name in a second method, right? So I can have another method that has a parameter called x. That's not a problem. Now every method has what's called a signature. So the signature turns out to be important in Java. The signature consists of the method name, the types in the parameter list, double, double. The names in the list are not part of the signature. So the signature of this method here is set double, double. Right. Well, that's the signature. So here's a bunch of other examples of signatures. Okay, so here are a bunch of headers of methods in string. So string has a method called toUpperCase, right, returns a string. The signature of this method is just toUpperCase. Okay, so the name of the method, it has no parameters, so the signature also has no parameters. Notice that the return type is not part of the signature, right? It's only the name and the type of the parameter. So car@ has a parameter called index, whose type is int, right, returns a car. Signature is just car@int. Let's look at the last one. So the last one, there's a getCars method, right? It has a parameter called sourceBegin, one called sourceEnd, one called destination, one called destination_begin, right? The signature of this thing is the name, so getCars, int, car array, int, right? So getCars, int, car array, int. And so those are the four signatures of the four method headers here. Now, why am I telling you all this? Because the signatures in a class must be unique. Right? Signatures in the class have to be unique, right? So that means you can have two methods with the same name, right? As long as their parameter lists are different. More importantly, sorry. So there's a cat scratching at my door. So I can make a method called set that has only a single double parameter. Well, sorry, just a second. She's being really obnoxious. Hang on. Hey, go away. All right. So you can add a second method to the class called set that only sets the x coordinate of the point. So it leaves the y coordinate unchanged, right? That's not necessarily 0 in this case, right? So you can set just the x coordinate of the point with this method here. Right? So now I have two, or I could have two methods called set. They have different signatures, right? The original set is set double, double. I now have set double, right? What I can't do is I cannot add a third method called set whose parameter name is y. And is also a double, right? Because now I have two methods that have the same signature, right? The name here doesn't matter. The return type here doesn't matter. The access modifier doesn't matter. It's just the method and the type. Right? These two have the same type, same signature, so they can't exist in the same class. Right? If you try to add that third method, or if you try to put both of these methods in the point2 class, the compiler will flag them both as errors, right? Because they have the same signature. You have to change the signature of one of them, right? Which forces you to either change the name, right? Or it forces you to change the type of the parameter, which in this case wouldn't make sense. If you have two methods with the same name, but they're overloaded, but they have different signatures, then the methods are said to be overloaded. So be careful with this term, because there's another term called overridden, which means something completely different. Okay? Overloaded method is just a method that has the same name as another method in the class. So in the point2 class, if you wanted to find the distance between 2 points, right, between this point and another point P, you could add a distance2 method, right? You can add 3 of them if you wanted to, right? So I can compute the distance to the point P, right? I can compute the distance to the point whose coordinates are X and Y, right? Where X and Y are both doubles. Or I can compute the distance to another point whose coordinates are X and Y, but their coordinates are represented as floats. Right? So these 3 methods, same name, different signatures, right? So they can all coexist in the same class. Methods with the same name are called, in the same class, are called overloaded methods. You're all C programmers. You can't have a function with the same name in the same compilation unit in C, right? That doesn't work. But it's very common to see in Java. What about the return types? So the return types, you know this already. All Java methods return either nothing, so that you indicate that with void, or it can return a single, or it can return a value of a single type. Right? It can return one value or nothing. Right? So that thing there, that's the return type. So this says the method X returns a double value. Methods common to all classes. Okay, so here's this starts to introduce the notion of inheritance in Java, but we'll look at this in a lot more detail as we continue through the course. So in Java, whenever you make a class, that class is actually what's called a child class or a subclass of this class java.lang.object. Right? Now, we don't actually need to know what child classes or subclasses are right now. Right? So we don't need to get into the details of all that. But what you do need to know is that because every class is a subclass of this, right, of a Java Lang object, that means every class has all of the methods that this class defines. So we've created our point2 class and our counter class and our stopwatch class, right? Our point2 class has a few methods in it right now, but it also has a bunch of other methods that came from here. It turns out, I think there are 11 of those methods in the current version of the language, but we only care about 3 of them. So our class, our point2 class, actually has a toString method. It actually has an equals method, and it actually has a hashcode method, right? Even though we haven't defined them, right? So the reason they're there is because they were inherited from that class there. So the toString method is supposed to, so the toString method is the method that you use when you want to get the string representation of an object, right? So when I want to print out an object to the console, right, I can use toString to get a quote unquote nice or human readable representation of the object, right? So for example, with our point2 class, right, if I make a point2 object whose coordinates are 0, 0, and then set the coordinates to -1 and 1.5, If I was to print out this point P, I would really like to see something like that. Right? It'd be really nice if I saw something like that, or something similar, right? Maybe squiggly brackets or maybe square brackets or something, right? But when I print out the point, I would really like to see it's the point -1, 1.5. So I can go ahead and define a toString method for the point2 class. Right? So toString always has that method header there. So when you implement toString, it always looks like that. The public string toString. So the method's called toString. It has no parameters. It always returns a reference to a string. Right? I would like to return a string, round bracket, x value, comma, space, y value, round bracket. Right? So that's easy enough to make. Right? Round bracket, x coordinate, comma, and space, y coordinate, round bracket. Right. So that's not hard at all to write. So it's easy to implement this method. If this was C, it becomes a bit harder, right? So in C, you're using like printf or something else to construct this string. But because Java overloads the plus operator for strings, it's pretty easy to return a string that's formed by concatenating a bunch of different values. Okay, now, this is funny. So this is the first time we've seen that thing there. So there's this funny @big O override thing sitting in front of the method. So you don't have to include this, right? If you left this out, your program would compile and run just fine. Okay. So that thing there is what's called an annotation. So an annotation always begins with an @. Now, up here, this is funny. So this is a Javadoc tag. So this is that's a big comment up here, right? So this is a special comment called a Javadoc comment, right? And that's how Java documents its code. Inside the Javadoc comment, you'll also see @, right? That's not an annotation. That's what's called a tag, right? So inside your source code, if you see one of these, that's what's called an annotation, right? So annotations are things that you can use to tell the compiler, to provide the compiler with extra information, right? In this case, @override is telling the compiler that this method here is replacing or redefining the toString method that came from the object class. Right? So you can use this tag here, this annotation here, when you are redefining a method that came from object. Right? So that's toString equals in hash code for our purposes. Now, what does this tag? What does that annotation tell the compiler? Right? It tells the compiler that this method here is supposed to override or redefine. That's what override means, right? Redefine a method that came from object. Will the compiler? Can you please check that this header here is correct, or the signature of this method is correct? Actually, it does more than it's more than the signature. It's actually the header. Parameters in so that's a good question. You have to remember that when I'm showing you all of these examples, they're all inside of a class somewhere. So here we go. Okay, give me 1 second to adjust my font size again. Okay, so here's our point2 class, right? You have access to all the source code, by the way, right? So if you import that project, that it's inside a zip file that's in part of the notes. If you import that project, you get all the source code, right? All of this stuff here. Thing that's there, you get. So here's our point2 class, right? There's our x and y. There are our fields x and y. there's our no argument constructor. Somewhere there's a toString method here. So here's the toString method. It's more complicated than what's on the slides, but this is another way of implementing it. Right? But there it is. Right. So the toString method is actually inside the point2 class. So when you say this dot x, you mean that x there. Right. So you mean that x there. When you say this dot y, you mean that y there. That's an example of using the outline view, by the way. Right. So if you're in a big class like point2, you just click on a method and it jumps straight to the method. So if we jump back to toString, right? This one uses a string builder object to construct the string. You don't have to do it this way. What's on the slides is fine. But when you say this dot x here, right, you mean the field x that's here. Right. So x and y. So this method here, it looks like, because it's on a single slide, right? It doesn't look like it's inside the point2 class. But you have to remember it's in the point2 class. Right? So it's not, you can't have a method that exists on its own Java, right? It's always inside of a class. That's one of the problems with teaching programming in PowerPoint, right? I can only ever show you a very small amount of code. So you have to keep in mind that this is actually inside of the point2 class. Okay. Oh, so that override thing. So when you write @override, you're telling the compiler that this is supposed to be overriding a method that's inherited from object. The compiler will actually check, is there a method that looks like this inside of object? Right? So it will actually go into the object class and look, is there something that's public string to string? Right? If the answer is yes, then everything's fine. Right? If the answer is no, the compiler will flag that as an error. Hey, wait, I've got Eclipse open. I can just show you that. Right? So let's go down to point2. Right? I've used the @override tag here. Right? So suppose I spell toString wrong. Right? So suppose I spell it like that. Right? Right away, you get this red thing here, and it tells you that the method toString, right, to_s_string of type point2 must override or implement a super type method. So it's complaining there is no method called to_s_string in the object class. Right? So the override tag lets the compiler check to see if this signature, if that header there is correct. Right, the error goes away. If I change the return type, right, so if I make the return type void, again, it's going to complain, right? So the return type is incompatible with object.toString, right? Again, it's saying, hey, look, you're overriding toString. It has to return a string. Right? If I change the access modifier to a more restrictive access modifier, so if I make it protected in this case, yeah, let's do protected. Again, it complains, right? Cannot reduce the visibility of the inherited method from object. Right? Now, public, if you comment out the override annotation, right, the compiler will no longer check if you change this. So if I write that, as far as the compiler is concerned, that's fine. Right? You just defined a method called to_string, right, inside your class, right? But it no longer overrides the object version of toString. Change the return type. It's going to complain about something else because I have a return statement here. So let me just comment that. Oh yeah, so now, so this one, Eclipse is actually a little bit smarter than I'm giving it credit for. It actually knows that this is, it's actually checked to see if this is an override. But that's because it's from object. If you were doing this on your own inside of a different inheritance hierarchy, you wouldn't get this error here. The @override annotation asks the compiler to check if you are in fact overriding, if in fact your method header is correct. Right? Are you actually overriding a method when you say that you are? Right? So that's what it's there for. It is optional, right? So you can in fact leave it out. Now, if you define toString, that lets people who use your class print out strings in a nice way. So you should always override toString if it makes sense to be able to print out your object. Right? It makes sense to print point2 objects, so we should override toString. So for example, I can make a little class called print point. In my main method, I can make a point, change the coordinates of the point, and then print the point. Right? How do I print the point? I say print line p dot toString. Right? Print line is magical though. Oh wait, I didn't tell you that. Print line is magical. If you don't call p toString, right? So in other words, if I just write p, it still works. You still get when you print p, you'll still get bracket -1 comma minus 1.5 bracket. Right. So that's because print line is overloaded to take in an object here. Pass in an object reference like p. Inside print line, it automatically calls p toString for you. So it doesn't matter how you call. It doesn't matter if you use p toString or just p in this case. You'll still get p, the point, printed out using our brand new toString method. 116. Can we do this? I think we can do this. Yeah, we can do this, sure. So that's our point 2 class. So we've got some constructors. Well, we have a constructor. We've got some methods. What about our counter class? So for our counter class, remember the counter is counting from 0 up, right, in increments of 1. So for the counter class, you probably want to provide a method that lets the user find out what is the current count. So that's method number 1, value of the counter. Method number 2, I want to let the user advance the counter by 1. I want the count to go up by 1. And I want to provide a toString method so that we can print out a counter in a nice way. So remember, here's our counter class, right? There's our constructor. I want to provide a method that returns the current value of the counter. Right? So in other words, I want to provide a method that returns that value there, right? So that's easy. It's just return this dot value. Name of the method I've chosen is value. Right? The method name happens to match the field name. That doesn't matter. Just type int. About incrementing the counter. So when you advance the counter, right? If you remember that what our counter class does, right? So it counts a value, but it can only count up to integer max value. You can count from 0, 1, 2, 3, 4, 5 up to integer max value. Now the contract for this method says if you advance past integer max value, the value wraps around to 0. Right? Now remember how ints work, right? If I have an int and I advance past integer max value, I go to integer min value, right? So I get some very large negative value. The counter class does something different. It wraps around to 0. So I have to write some code to do that. Right, so how does advance work? Okay, so if the value is not integer max value, just add 1 to the value. Now, if the value is equal to that, right, so it's currently the largest int value that I can represent, set the value to 0. That's it. That's easy to implement just with a single if statement. Finally, what about toString? Well, so for toString, now the choice is yours on how you implement this, right? So whoever is creating the class gets to decide what does the string representation look like. I've decided that the string representation is going to look like the word count, colon, space, followed by the value, right? And that's documented up here. So whatever your contract says, that's what you should try to implement. You could choose to do something else, right? Like you could choose to print the value inside square brackets or in round brackets or in squiggly brackets or something else, right? Anything's fine as long as it's consistent, right, with the contract of the method. Okay, so that's a good place to stop, I think. Yes, that's a good place to stop because the stopwatch is a little bit more complicated. Okay, so you learned quite a lot today, right? You learned about fields in a class, how to use them, how to set them. Right? You learn how to create constructors, and you learn how to create methods. So there was quite a bit in this lecture. Does anyone have any questions about today's lecture? All right. If you aren't reading the notebooks, I would encourage you to actually start reading them. In particular, if you haven't programmed in an object-oriented programming language before, I would strongly encourage you to start looking at the notebooks, part 2 of the notes. right? Because they tell you how to do all of this, and they go into pretty good detail on how to do this. And I think there's 4 different classes that it goes through. Okay. So I encourage you to start reading them now if you haven't been. All right, that's all I have for today. A general question: can you call a class from another? You absolutely can, right? So, and we've been doing it already. So, if you want to use the list class, right, or if you want to use an array list, you have to import the array list, right? So you import Java util array list, and then you can use the array list in your program, which is definitely not in the package java.util, right? Because you can't put one there anyway. I don't think you can put one there. So yeah, so I can make a class in my own package, import another class, and then use it. Right? But you have to import it.
Do you know why I'd be getting an error if I'm trying to import the class?
It's either not in the package that you're importing it from, or the compiler can't find the package that you're importing from. So I'd have to see the exact. So you'd have to read the error to find out exactly what's going on.
Because it can't resolve it. It can't resolve it to a type or something like that.
Yeah. That's saying that it doesn't know where this package is. So the question is so what are you trying to import?
So I just made a class in a package called Lecture 12 from last class. Good. And I was trying to import the .2, like I was trying to create a .2p. So I was trying to import .2, which is under the lab2 class.
Yep.
So I tried importing lab2.2.
Yeah.
I tried doing.
Is it all in the same project, or is it in a different project?
Is project the overarching?
The lab2. There's a lab2 project, and then there's. Did you put the lecture 2 or 12 class inside the lab2 project?
No.
Yeah. So you can't access a package from another project.
Oh, okay. So okay. Okay, as simple as that. Okay, thank you.
Yeah. Okay. Anything else? So I'm not seeing anything.
If you override